So to find the reading on this venturi meter, for part A, we have the equation of continuity and Bernoulli's equation. So we can say that A sub 1, this will be the equation of continuity, A sub 1, V sub 1 equals A sub 2, V sub 2. So the volumetric flow rate is constant. And then we can say that V sub 2 equals A sub 1, V sub 1 divided by A sub 2. So that would be that. And then we can say that we can use Bernoulli's equation where delta y equals 0 meters. So essentially we'll have P sub 1 plus half of rho V sub 1 squared equals P sub 2 plus half of rho V sub 2 squared. And at this point, we can solve and say that 2 times P sub 1 minus P sub 2 divided by rho is going to equal V sub 2 squared minus V sub 1 squared. And this is going to equal, we can sub in for V sub 2 squared and say A sub 1, V sub 1 over A sub 2. This will be squared minus V sub 1 squared. And at this point, we find that, let's get a new workbook, V sub 1 squared times A sub 1 squared minus A sub 2 squared minus A sub 2 squared divided by A sub 2 squared is going to equal 2 times P sub 1 minus P sub 2 divided by rho. So we can say that V sub 1 squared is going to be equal to 2A sub 2 squared P sub 1 minus P sub 2 all divided by rho times A sub 1 squared minus A sub 2 squared. So we figured out that V sub 1 equals A sub 2, and then it'll be times 2 P sub 1 minus P sub 2 divided by rho A sub 1 squared minus A sub 2 squared. And this will all be to the 1/2 power. So this is exactly what they're getting in the givens. So this would be your final answer. And this would be the full derivation of the venturi meter. Now, for part B, they're saying that D sub 1 equals 3.5 centimeters. So we can say that R sub 1 is going to be equal to, rather, let's just keep it as D sub 1, and we can just convert to meters immediately. So this will be equal to 0.035 meters, and then D sub 2 is equal to 1.0 centimeters or 0.01 meters. And delta P is going to be equal to 18 millimeters of mercury, and we're going to multiply this by 133 pascals for every millimeter of mercury. So we can get 2,394 pascals. And as an aside, we know that A is equal to pi r squared. So we're going to set this equal to pi d squared over 4. And at this point, we can solve. So V sub 1 is going to be equal to pi times 0.01 squared divided by 4. And then we're going to use that. We're still using that same equation. So we're going to just say the density of water, 1,000. And then it'll be pi squared 0.035 to the 4th divided by 16 minus pi squared 0.01 to the 4th divided by, again, 16 And then on the numerator, we'll have 2 times 2,394, all to the 1/2 power. And we find that this is going to be equal to 0.18 meters per second. So this will be our answer. This will be V sub 1. And that's the end of the solution. Thank you for watching.